Let's do one more example of finding the derivative function using the limit definition of the derivative. Here we want to use the limit definition of the derivative to find the derivative of f of x equals 5x squared minus 6x plus 1. And then we want to find an equation of the line tangent to this graph at the given value of a, and here a is equal to 2. So a is our given x value. We know that the derivative of a function is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. To find f of x plus h, wherever we see an x in the original function, we substitute in x plus h. So that gives us 5 times the sum x plus h squared minus 6 times the sum x plus h plus 1. Minus f of x is equal to minus the entire f of x. So minus 5x squared minus 6x plus 1. And that's all over h. Now let's start simplifying the numerator first by FOILing out or by squaring the binomial x plus h. Squaring the binomial x plus h gives us x squared plus 2xh plus h squared. Distributing the minus 6 to the x plus h gives us minus 6x minus 6h, and we bring the plus 1 down. Now let's distribute the minus to the 5x squared minus 6x plus 1. That gives us minus 5x squared plus 6x minus 1, and that's still all over h. Let's continue simplifying the numerator by distributing the 5 to the x squared plus 2xh plus h squared. That'll give us 5x squared plus 10xh plus 5h squared. Bring everything else straight down, and that's still all over h. 5x squared and minus 5x squared cancel out. Minus 6x and plus 6x cancel out. Plus 1 and minus 1 also cancel out. And that leaves us with the limit as h approaches 0 of 10xh plus 5h squared minus 6h all over h. Now we're still not free to go ahead and substitute 0 in for h, because doing that will still give us a 0 in the denominator of our fraction. So the next thing we're going to do here is factor an h from each term in the numerator. That gives us this expression. And now we see that the h in the numerator will cancel out with the h in the denominator. And that gives us the limit as h approaches 0 of 10x plus 5h minus 6. Now we can go ahead and substitute in 0 for h, because substituting 0 in for h doesn't leave us with a 0 in the denominator any longer. Substituting 0 in for h gives us 10x plus 5 times 0 minus 6, which is just 10x minus 6. And this is our slope function, or our derivative. Now we need to evaluate the derivative function when x is equal to 2 to find the slope of the tangent line when x is equal to 2. So the slope of the tangent line when x equals 2 is 14. Now let's use that information to come up with the equation for the tangent line. And we'll use the point slope form of the equation of a line to do that. But in this case, we notice that we don't have a y coordinate. We only have an x coordinate. Well, to find the y coordinate, we can use the x coordinate. We just simply plug in 2 wherever we see an x into our original function, and that'll get us the y value that goes with that x value of 2. So the equation of our line is y minus the original function evaluated at 2, that's our y sub 1, is equal to 14 times x minus 2. Evaluating the original function when x is equal to 2 gives us 9. So the left side of our equation is y minus 9. And simplifying the right side of this equation gives us 14x minus 28. So we have y minus 9 equals 14x minus 28. Let's now add 9 to both sides to isolate y. And that results in y equals 14x minus 19, which is the equation of the tangent line to this function when x equals 2.